All right, welcome to Simplifying Radicals Pre-Assessment. And there are a couple things we're going to be simplifying. Radicals. And we're going to be simplifying rational and irrational radicals. Then we're going to be adding and subtracting radicals. And then third thing that we're going to do, let's move that down just a tad so we can get that third thing, is we're going to be multiplying. Some of you learned how to divide. We're not going to do that. We're just going to do simplifying, adding, subtracting, and multiplying. So let's take a look at this. We're going to simplify. We have to determine, is this a perfect square or is it a radical that can be simplified? Does it have a perfect square factor? 72 is not a perfect square. We should be memorizing all of our perfect squares. If we want a list of perfect squares: square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, square root of 144. These are all perfect squares. They produce whole numbers. Oh, I was about to do 9. No, Mr. Mac, that's not. Square root of 9 is 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and they continue on to infinity. So those are ones that we should recognize and be familiar with. 72 is not one of those. However, can I break 72 into one of these factor pairs? Yeah. 4 goes into that. So 4 goes into 72. Or even better, I just changed my mind. How about 9 and 8? 9 times 8 is 72. And square root of 9 is a perfect square. That's why I chose that factor pair. I could have done 4 because 4 is a perfect square, but I'm going to try to do the biggest one that I can see. So the square root of 9 equals 3. Now, square root of 8 can still be simplified. So don't leave it as 3 rad 8 because square root of 8 has a perfect square inside of it also. So notice that we have to simplify it completely. And then 3 and 2 are outside. These are coefficients. 3 times 2 is 6, rad 2. So once we take the square root, it becomes a whole number outside of that radical. Good. 108, 9 and 12. 9 times 12 is 108. 9 is a perfect square. 12 has a perfect square factor inside of it. So 3 times 2, rad 3, which becomes 6 rad 3. Good. So those are the first two. 112. All right, 112. So I'm looking, thinking, does 4? 4 goes into it. So 4 goes into it. 2 and 8, 28. So 4 becomes 2. Now I'm looking at rad 28. Is there a perfect square? Yeah. 4 goes into that 7 times. So it's 2. So that becomes 4 rad 7. 147. Well, 7 goes into it. I don't know if 7's not a perfect square, but I'm just looking to see, and that becomes 21. So now, and we've talked about this, now I'm going to look to see if I can match it. Can I match this radical from this group, from this radical? Yeah, I can break rad 21 into rad 7, rad 3. So I found that match. These, and if we have a square root times itself, that will cancel the radical and leave us with the base number. So that's an interesting way of going about doing it. I got lucky. So if this was another number that like 22, that wouldn't work. And so some of these radicals cannot be simplified. So I'm going to try 4 again. 4 goes into that 1, goes into it 2, and goes into it 8, I think. 5 is 1 left over. 8, 3, yep, 128. So this is 2. 4 goes into that. So we'll break that into rad 4, and that is 32. So this is 2 times 2. Rad 32 is rad 16 times rad 2. So this is 4. This is going to give me 4 rad 2, and we get 16 rad 2. So sometimes we just nibble away and try to just get it smaller, smaller, smaller. Do the things that you know. So now this is our first with a coefficient. So when we see a coefficient, it's multiplying. There's multiplication going on here. So rad 32, as we just saw, is 16 times 2, and 16 is a perfect square. So negative 4 times 4 is negative 16 rad 2. We can have negative coefficients, we just can't have negative radicals inside. So this is negative. This is a perfect square, so this just becomes negative 6. We have 4 times 147. We've seen this before. So we saw 7 and 21. And then we're going to make rad 21, rad 7, rad 3. So that's 4 times 7 rad 3, and we get 28 rad 3. The more familiar you are, 147, hello. All right, so we know that that's going to be 7 times 7 times 3, rad 3. 8 times 7, rad 3. Mr. Mack could have seen that we were making the same number, negative 56 rad 3. 256, all right, that's a big one, 256. I'm going to go 4. So 4 goes 64 times. That's cool. Look at that. That's fun. Perfect square and perfect square. So 8 times negative 8 is negative 64 times 2 is negative 128. No calculator needed, folks. We can do all this work by ourselves. All right, now we're adding and subtracting. So when adding and subtracting, we have to have like terms. So like terms means same radical. So same radical. So these have the same radicals. We're going to combine their coefficients. Coefficient in front of these, we're going to combine coefficient. So 1 plus 1 is 2 rad 3. The radical doesn't cancel because we are adding. Radicals only cancel when we multiply. Multiplying the same radical cancels out the radical. Adding the same radical, you combine their coefficients. These are like radicals, so this becomes 2 rad 12. Now, make sure that your radicals are simplified. So rad 12 can be simplified after I added their coefficients. So we get 4 rad 3. Make sure you simplify. Rad 13 plus rad 13, 2 rad 13. Rad 7 plus rad 7, 2 rad 7. Rad 8, 2 rad 8. And I got to simplify. Rad 8 can be broken into rad 4, rad 2. 2 times 2 times rad 2, which is 4 rad 2. Now we have coefficients. We've got like radicals. We're going to look at those coefficients, negative 4 and positive 7, which leaves me with 3 rad 2. -7, -1 makes -8 rad 11. We don't take the square root of 8 because there's no radical. This is the coefficient. That does not have a radical sign. -1 and 3 makes 2 rad 8, and then we have to simplify rad 8 to make it 2 times 2 rad 2, or 4 rad 2. Ooh, I like this one. So 4 minus 4 is 0 rad 15, and you must simplify it to 0. This is the only answer. This is the answer. Do not give me 0 rad 15. Must simplify. You must simplify that. 0 times rad 15 gives you 0. If you leave it like that, it hasn't been simplified. This is -7. This is +3, so we get -4 rad 15. Rad 15 can't be simplified. Ooh, now these are unlike terms. And we should notice I can simplify that, and I can probably simplify that. So I'm going to simplify this to rad 4 rad 2, which becomes 2 rad 2. And now I'm going to simplify this. So 4 goes into that also, rad 4. And 128 is 32. So rad 4 is 2. Rad 32 is rad 16 rad 2. So we're just bringing this along. This becomes 2 times 4 rad 2. And that's 2 rad 2 plus 8 rad 2. Now they are like terms, so we combine their coefficients. 2 and 8 make 10 rad 2. 150, rad 25. And that goes in 6 times, so that's 5 rad 6. And we have this rad 6 that comes down and along. Now we have like terms, add their coefficients, 6 rad 6. There's a 5 there, there's a 1 there. 150 and 54, we just did that. That's rad 25, rad 6, which becomes 5 rad 6. 54, 9 and 6. So as we see, knowing your times tables and how to multiply and what makes 54 is very beneficial. So the more familiar you are with your times tables, the easier breaking up and finding factor pairs are going to be for you. 128, I think we just did that. That is 4 and 32. So that becomes 2, and that's rad 16 rad 2, which becomes 2 times 4 rad 2, or 8 rad 2. This 32, oh, I could have done that. That would have been fun. I didn't see that those were like, I could have made this 2 rad 32 and added to that one, but that's fine. We can still get there. 16, 2 plus 4 rad 2 plus 4 rad 2 plus 4 rad 2, which makes 12 rad 2. Got to keep track. Your work has to be organized. That's going to be 2 rad 2. That's a nice easy one. Ooh, I almost combined those. These are not like terms, so we're going to have to simplify rad 72, which is 9 times 8, which is -2 times 3 rad 8, which is -6. We'll break the rad 8 into rad 4 rad 2, which is -6 times 2 rad 2, which makes -12 rad 2. Now let's deal with the other one. 98. I should probably remember what 98 was. What was 98? 7? 7. Yeah, but 7 and 28. 7? No, 7 and 14. Oh, okay. 7 and 14. 7 times rad 14. So I'm going to break up this rad 14 into rad 7 rad 2. And now we matched. So that's 4 times 7 rad 2, or -28 rad 2 minus 28 rad 2. And that makes -40 rad 2. All right. Sometimes it doesn't have to be pretty. I got lucky again. Ooh, 208. All right, these are some big numbers now, baby. 208. Well, 4. 4 goes into that. 4 goes into that 52 times. Ooh, that's an interesting one. So that's 5 times 2. 52. 5, 6, 7. 4. 4 goes into it again. 4 goes into it 13 times. So that's negative 10 times 2 rad 13, which makes negative 20 rad 13. And then we have our 5 rad 13 that we will just bring down along for the ride until we have a like term, which we do here. Negative 20, positive 5 makes negative 15 rad 13. This is easy. You like this one. This becomes 2 times 2 rad 2 or 4 rad 2. This is an interesting monstrosity. Does 4 go into it? 4 goes into it. Wow. Okay. That's negative 5 times 4. And 4 goes into 392. Goes into it 36, which is 9. 36 with 32, 8. So 98. Wow, that's an interesting number. So that's times 2, 98. 98. Does 7 go into 98? 7, yeah. Did we do 98 already? 7. 7 goes into it. Now maybe 7 doesn't work, but we'll see. 7 goes into it 14 times. We must have done 98 already. 98 we did. 98, so that's negative 10. We're going to break rad 14 into rad 7, rad 2. We've matched these. So we have 4 rad 2 minus 10 times 7 rad 2. The 7 came from that. So we have 4 rad 2 minus 70 rad 2. And that gives us an answer of negative 66 rad 2. Don't forget those negatives. All right. Whoa, my goodness. Hi-ya. All right. 54 and 10. That doesn't really benefit us, does it? No. All right. Let's start with our sturdy 4. 4 goes into that. And 4 goes into that 1, 3, 5, 135. Is that true? That's 114 is 20. Yeah, 135. Okay. Negative 3 times 2 and 135. 25 doesn't go into it. I mean, I'll try 5 just to see what we get as a leftover. I may have to come back and erase it, but that's going to be 27. Okay. Now, that doesn't help. There's no match there. This is negative 6. However, 27 has a 9 in it. So you'll like this one. This one will be fun and interesting. So here's my perfect square. So this is negative 6 times 3. Now, I've got these 2 leftovers that don't have any like in it. So I'm going to just multiply those back together to make rad 15. So this is negative 18 rad 15. That's an interesting one. This is a good one to practice. Plus 5, 24. Well, 4 goes into that, we know. 4 goes into it 60 times? Yeah. So that's plus 5 times 2, 60. 60 is 4 times 15. So that's going to be plus 10 times 2 rad 15, which gives us 20 rad 15 plus 20 rad 15, which nicely cleans up to 5 rad 15. All right, big numbers. We can still do it. We got this. I'm going to make this 25 and 6. which is 5 times 5 rad 6, or 25 rad 6. 216. 9 goes into it, so I'm going to break that into rad 9. 9 goes into that 18, 36, 24. So 2 times 3, 24 is 4 times rad 6. So that's 6 times 2 rad 6. Bring down the 25 rad 6 plus 12 rad 6. 37 rad 6. Nice. Let's make sure, just checking. 2 times 3 is 6. Times 2 is 12. Yep, those are good. That can't be simplified. 200. 200 is 4. 100. Hello. 100 times rad 2. So negative 5 rad 5 plus 3 times 10 rad 2. Negative 5 rad 5 plus 30 rad 2. Now let's deal with this. Negative 3 is rad 4 rad 5 minus 3 times 2 rad 5, which is negative 6 rad 5. We've got like terms here. Both have rad 5s. That would make negative 11 rad 5 plus 30 rad 2. And that's our answer. We can't combine these two. 4, that's rad 25 rad 6. 4 times 5 rad 6. 20 rad 6 plus 5 rad 2 plus 5 rad 2 plus 5 rad 2 cannot be simplified. Oh, hello. If I just took a second and took my time, I would have seen that those are the same. So I know that that's going to simplify to 20 rad 6. I don't have to do the work again, even though I didn't notice it, but I know that it's going to simplify to 20 rad 6, giving us 40 rad 6 plus 5 rad 2. 48, is that 16 times 3? I think that's 16 times 3 is 18 carry. Yep. So that's 5 times 4 rad 3, or 20 rad 3. 4 rad 8, rad 4, rad 2, which is 4 times 2 rad 2, which is 8 rad 2. And then we have 4 rad 12, which is rad 4 rad 3. 4 times 2 rad 3, which is 8 rad 3. We've got like terms, rad 3, rad 3s. 28 rad 3 plus 8 rad 2. Okay, can't break it down. Not like terms. This will break into rad 16 rad 2. So negative 5 rad 3 minus 2 rad 2 plus 5 times 4 rad 2. Negative 5 rad 3 minus 2 rad 2 plus 20 rad 2. Negative 5 rad 3. Negative 2 and positive 20 makes positive 18 rad 2. All right. Oh, 35, still there. Notice I took a second. I took a second to look at the problem before I just started on the first one. So this can be simplified first. Silly. And now we can simplify. Then we can reduce this radical. So 7 rad 4 rad 2. 7 times 2 rad 2. 14 rad 2. We'll bring down that 5 rad 2. Bring down the 5 rad 2. They are like terms, making 19 rad 2. All right. Multiplication. Multiplying. We're going to look for two things. We're going to look to see if there are any matches. Can we match radicals? If we match the radicals, it cancels out the radical. And then the other one is perfect square. We're going to look for perfect squares in these. So not a perfect square, not a perfect square. So I'm going to break 14 into rad 7, rad 2, because it's going to match with this rad 2. And rad 2 times rad 2 is 2 rad 7. So once we can find that match, it cancels the radical and we get the base outside as a coefficient. So we're never going to multiply these to make 150. 150. 5 times 3 is 50. Oh, no, 1,500. We're never going to multiply them. We're always going to look to see, can I break them down? I'm not going to build up just to break down. So 50 I'm going to break into rad 5, rad 10. 30 I'm going to break into rad 10, rad 3. These are my matches. They match coming out of the radical. And then I have these leftovers. There are no common factors. Can't break them down, and they don't cancel each other. So I'm going to multiply them back. This is the only time that I'm multiplying radicals because I need to simplify them as an answer. This is an interesting one. So I'm going to make this, I'm going to rad 4, rad 3, and I'm going to leave rad 10 because I could break it into 2 and 5, but that wouldn't cancel the 3. So there's no reason to break this down. This is a perfect square, so that's why I chose 4 and 3. That gives me 2, but we're left with rad 3 and rad 10, so that's just rad 30. Rad 30 cannot be simplified. Rad 20, rad 40. I'm going to leave rad 20 and I'm going to break rad 40 into rad 20, rad 2. A lot of people would break it into 2 and 10, 4 and 10, cancel the 10s, but I actually have a bigger number that they have in common. So this is 20 rad 2. That's efficient. I like this. No common factors, so we just need to multiply them and can't be simplified. That's a real good one. That's rad 9, rad 10 times 3 times rad 3, rad 10. So a couple things here. I've got my two outsides. Those are coefficients. 2 times 3 is 6. Now I've got a perfect square. Square root of 9 is 3. Then I've got a match here, 10 and 10, which rad 10 times rad 10 cancels and leaves me with 10. And then I've got this left over here. Rad 3 stays in the radical. 6 times 3 is 18 times 10 is 180. Rad 3. Like that problem. That's a good one. 48. I think that's 16 and 3. 16 and 3. Then we'll break 3 into 3 and 10. So I've got my coefficients outside. 5 is outside 3, so makes 15. I've got a perfect square here, which is 4. And then I've got a match also. I've got a match here that I can, what color do we want? We want that color. We can match those. Rad 3 times rad 3 equals 3. And then we've got our leftover rad 10. So how would we want to do that? Well, that's 60. And then 60 times 3 is 180 rad 10. Okay. That wasn't too bad. Again, no calculator needed. Don't let this negative. This is multiplication. This is not addition and subtraction. When you first looked at it, it kind of looks like subtraction. That's just a coefficient. Everything's still being multiplied. That's 8 times rad 8 times negative 4 times rad 4. So I've got my 8. I'm going to break this into rad 4, rad 2. I've got negative 4 times rad 4. So let's talk. That's 8 is outside. Rad 4 is 2. Rad 2, negative 4, and this is 2 also. So I like that. What's outside? We've got 8 times negative 4, which is negative 32. Double that, which is negative 64. Double that is negative 128. Negative 128 rad 2. right? 8, 32. 32 is 64. 64 is 128. Yep. 10 times, we'll do rad 6, rad 10. This is a -1 times -1 times rad 5, rad 10. So we have 10. We've got the match here. So we got 10 times 10 times -1. And then these leftovers don't have a common factor, so that's going to make rad 30. So that's 100, so -100 rad 30. That's a good one. And the last one, yay! Rad 2, that's a -1. We'll break that into rad 2, rad 5. We've got the match here. So -2, what? Where'd the negative come from, Mr. Mac? That was weird. I caught it though, because I'm not rushing. I'm still staying connected. 2. Rad 2 times rad 2 is 2 times -1. And then rad 5. 2 times 2 is 4 times -1 is -4. Wow, that was an ugly 5 on the last one. 5. Still a little ugly. All right. That's all you need to know. Good luck with it. Hopefully you saw some patterns. You saw some key techniques on how we do this. And that was relatively quick. So again, each problem should take no more than 30 seconds. Good luck.